Let's talk about these 5 major types of chemical reactions. We'll look at examples of each and learn how to tell them apart so that you can look at a chemical reaction and classify it, figure out what type it is. The first reaction, replacement reactions, break my heart, and in a minute you'll see why. So in a single replacement reaction, what happens is that one element that starts out by itself replaces another element in a compound, kicking it out. And here's an example to show you what I mean. We start out with iron, Fe, which is this element that's by itself. And iron combines with CuCl2, which is copper chloride. Okay, so copper and chloride are paired up here. But what happens is iron kicks out the copper, the Cu. So the Cu ends up by itself, and the Fe, the iron, takes the place of that copper. So now the iron and the Cl, they are now paired up. Now I like to use a dance analogy to explain this, and it reminds me of something that happened all the time in high school. Here's what's going on. We have a dancing couple, the purple and the green. And they're so happy dancing together, or at least the purple guy is pretty happy dancing. And then red comes along, and red is like, hey purple, I'm so much cooler, get out of the way, I want to dance with green. And so poor purple gets booted out, and red ends up dancing with green. Purple ends up all by himself, standing up against the wall, pretending to text, pretending to play a game on his cell phone, but you know, he's really actually sad because he's just been booted from this dancing couple. So you'll see that this is exactly what's going on in the single replacement reaction, right? Fe, iron, is like red here, coming up to a dancing couple of Cu and Cl. It boots out Cu, Cu ends up by itself, and then red, iron, takes the place that Cu had, and iron ends up paired with Cl. Here's one more example of a single replacement reaction. You can see how this works. Cu in this case is the red character, and Cu goes to a dancing couple of Ag, silver, and nitrate, AgNO3. Cu boots out Ag, so Ag ends up by itself, and Cu takes Ag's place by pairing up with NO3. So that is how a single replacement reaction happens. And a generalized reaction for that would look like A, which is the element that starts out by itself, plus Bc, that's the dancing couple, and then that gives us B by itself, which is this element that got booted out, and then A and C ending up paired together. So that's a single replacement reaction. So finally, here's the double replacement reaction. Now I should mention that single and double replacement reactions are sometimes also called single displacement and double displacement, just in case your teacher textbook uses a different term for them. Okay, so double replacement reactions are not nearly as heartbreaking as single replacement reactions. Here's why. Because in a double replacement reaction, what happens is the positive and negative ions in two compounds just switch places. Nobody gets kicked out in a double replacement reaction. In a double replacement reaction, it's just like you have two different pairs of dancing couples, and the red, which used to be with the gray, ends up with the green, and the purple, which used to be with the green, ends up with the gray. Nobody gets kicked out, nobody's sad up against the wall with their cell phones, we're just switching dancing partners. So here is a chemical equation that shows a double replacement reaction. We start out with Ba and Cl together, and then Na and SO4 together, and they just switch places. So Ba ends up with SO4, there it is, and Na ends up with Cl, there it is right there. All of these compounds are ionic, which means that we can break them down into the positive and negative ions that they're made up of. So here, the positive ions are in purple, and the negative ions are in green. And as you can see, the positive and the negative just switch places. So Ba2+ and Cl- were initially paired up. But then Ba goes and it gets switched. It finds a new dancing partner. It has to find the other negative ion, right? So the other negative ion here is SO4 2-. So Ba2+ and SO4 2- end up together, making BaSO4. And then sodium, Na1+, has to find the other negative ion, which here is Cl-, and they end up paired up over here. Na1 plus and Cl1 minus, making NaCl. Here's another example of a double replacement reaction, okay? I'll break this down into its ions right away, and we get this. We start with K plus and Br minus paired together, and Ag1 plus and NO3 minus paired together, and then they just switch the positive and negative. So K plus goes and finds the other negative ion, which here is NO3 minus. K plus and NO3 minus end up together, and Ag1 plus, silver, looks for the other negative ion, which is Br1 minus, and Ag1 plus and Br1 minus end up paired up together, making AgBr. So that is a double replacement reaction, and if we wanted to come up with a general or generic way to explain it, we could use this reaction here, where we have AB, where A and B are paired up, plus CD, where C and D are paired up, and then they switch partners to give us AD and BC. So that is a double replacement reaction. Types of chemical reactions. In the next video, we'll do some practice problems so you can look at a bunch of different reactions and figure out what type they are.